So I thought it'd be a good time to stop now and do a little bit of planet by planet comparison. Turns out that, as I might have mentioned in an earlier video, marching through these planets can be a bit dull, but the comparison between them is quite interesting. So that's sort of what we'll stick with as our theme here for covering the planets. So we've covered Mercury, we know a few things about that. We've covered Venus, and we don't have to cover Earth. If you want the detailed view of Earth, you should take a geology class. But we know enough about Earth because we live here to go ahead and put it on a chart like this. And we'll get to Mars coming up in a few more videos and get this column filled out for Mars in time. But at the moment here, let's just stop for a moment here and talk about what we know about the planet. So Mercury, though, being as close to the sun, you might think it's very, very hot all the time, but it's not so. In fact, Mercury does have hot and cold regions depending on if it's illuminated by the sun or not. So in the hot case, it can get as high as 332 degrees Fahrenheit. In the cold case, it can drop to minus 272 degrees Fahrenheit. So please don't memorize any numbers like this. That's not going to be sort of be our emphasis here, but just keep in mind that there are some very extreme temperatures, despite the fact it's the closest to the sun. You might think it's going to be the warmest. Not so. Venus, of course, is all that can be said about it is it's hot, hot, hot right there. That's the one that's 800 degrees sort of, all the time, everywhere. And it doesn't matter where you are, whether you're on the side that's being illuminated by the sun or not, it's just going to be hot. The Earth, of course, here is livable. The hottest temperatures are generally maybe in the deserts and summers and things, 130 degrees Fahrenheit. And of course, some of the coldest temperatures can be minus 50. So that's sort of what we get on Earth here. And Mars, as we'll see as we get there, is going to be a very cold planet as well. But we'll get to Mars there soon, okay? In terms of the size here, you know that Mercury is very, very small and with that huge core. Venus basically is Earth-sized. And of course, Earth here is the size of the Earth. And Mars here is sort of about half the size of Earth. So it's kind of a small planet. So I'll go ahead and just sort of maybe characterize Mars here as being small, of course, relative to the Earth. Okay. Then you get to the geology here. And Mercury, of course, has none. No plate tectonics, no volcanoes, anything like that. Venus here has no geology that we're able to see in terms of plate tectonics. I do think there's still some active volcanoes on there, but there's definitely like none of this, no plates going on. Let me just say that. That's sort of important for this. So without the plates, there's no subduction zones, there's no erasing of craters and that sort of thing. But of course, the volcanoes, as we know, that we think are still active, are just found over weak spots in the crust where the lava can get through. And of course, the answer to the geology on Earth is, of course, yes. Earth does have that active geology. We know we have earthquakes and volcanoes and all those sort of things happening here. And of course, on Mars here, there's not going to be any geology to speak of. Okay. In terms of the rotation, then, Mercury's rotation is quite slow. Venus's rotation is also slow. And Earth here, let's say, the once in 24 hours, we'll sort of characterize that as kind of fast. The whole planet spins around in 24 hours. And Mars also has very similar rotation, sort of once in about 24 plus hours, a tad bit more than 24 hours. So we'll characterize that as fast as well. And I hope as you start thinking back, when you start mixing the geology and the rotation rate here, you might start thinking about the magnetic field prospects, but on we go, we'll get there, okay? Mercury has no atmosphere to speak of, and of course, Venus has the very, very thick CO2 atmosphere, right? The very thick carbon dioxide atmosphere. Earth has, of course, the nice atmosphere that we just love to go out and breathe. We'll classify the atmosphere as relatively thick, and of course, we're the nitrogen oxygen atmosphere. And then we go to Mars here. There's a very, in terms of the atmosphere, very thin or really none, okay? And so what you can think of with, as we get to this line here, is you can start thinking about the warming, like the planets that don't have an atmosphere, either very thin or none. There's none of the gases, like the greenhouse gases surrounding them, maybe to warm them up. And so you might start being able to infer what the temperatures might be like on some planets like that, versus the ones that have the thick atmosphere with either the carbon dioxide, where Venus is very hot, or our atmosphere, which is primarily nitrogen and oxygen. But of course, as you know, there's the issue of now the 400 ppm of carbon dioxide, sort of that key indicator that sort of keeps creeping up and might be warming us up. So keep that in mind. And then the magnetic field issue here. Mercury has a very small one, and I'll put a question mark there because we don't know the origin of that magnetic field. Very slow rotation, no active geology, maybe some remnants from that massive iron core, who knows. Venus here has no magnetic field to speak of either, likely because of its slow rotation. The Earth, of course, has a magnetic field. Yes, it does. And then Mars here has really no magnetic field to speak of, or a very small one. And so you can start piecing the things together again about the geology and so on and so forth, because some of the planets don't seem to have that spinning core that can definitely generate a magnetic field. And the Goldilocks thing here is kind of a funny thing here, but it's actually a term that comes up a lot in astronomy in terms of a planet being habitable. In other words, can you live on the planet? And Mercury here is going to be sort of like, maybe like too hot or too cold, right? You just sort of wouldn't want to be on a planet that has these massive temperature swings like that. Venus here is too hot. Mars here is too cold. And just in the spirit of Goldilocks, the three bears, you would just call the Earth just right. Okay, so that's sort of where the Goldilocks terms comes from. You look at a planet and go, that one's too hot and too cold. This one's too cold. This one's too hot. This one's just right. Maybe we should go live there. Okay, so that's our comparison of the three planets up to this point. And again, Mars is coming up here, but I thought we'd just give you a little preview of what happens. And the takeaway from this chart here is that you sort of have these four planets from the Sun: Mercury, Venus, Earth, and Mars. And boy, oh boy, they just couldn't be any more different, could they? You can just see from this chart here, the key parameters that you would look at for planets are just all over the map. And so you can see that they're just very different, even though they're sort of collectively closest to the Sun. They're the first four. They're the terrestrial planets. They might be very similar, but they are not.